To my case study circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. In this problem statement, we have a cone of base diameter 40 mm and axis length 50 mm, which is resting on HP on a point on the circumference of its base, such that its apex is at 40 mm above the HP and its top view of the axis is inclined at 60 degrees to VP. Also, we need to draw the top and front views of the solid and determine the inclinations of the axis when the base is nearer to the observer. So it is very clearly stated that the given type of the solid here is a cone having the base diameter of 40 mm and also the axis length is 50 mm. Next condition is the inclination with respect to the HP. So here it is not the base or the axis inclination as we have seen in the other problems, but it is telling that the apex is at a distance of 40 mm from the HP or from the reference line. And also the top view of the axis is inclined at 60 degrees to the HP. So very clearly it is told that the angle given to us is the beta angle, because the top view of the axis is nothing but the apparent view of the axis, and that axis is inclined at 60 degrees to the VP. So the given angle itself is the beta angle. So with this data, let us see how to draft the solution for this problem statement. Let us begin by constructing the XY line of thickness 0.18 mm. So draw a line of any arbitrary length, select the text from the annotation and annotate the line as X and Y, and also the reference planes as VP and HP. Now let us draw the top view of the cone, which appears to be a circle of diameter 40 mm. So this is the top view of the cone. In order to generate the slant generators and the other generators of the cone in the front view, we need to divide the circle into 8 equal parts so that we get some reference points on the circumference of the circle. So for that purpose, let us select a line of thickness 0.13, and from the center, let me draw a radii at 90 degrees and a radii at 0 degrees, and also a radii at 45 degree, and similarly one more radii from the center point at an angle of 135 degrees. Now let me use the extend to next option and extend this radii to be the diameters. So you can just see that the circle is divided into 8 equal parts, and the end points of each of the diameter lines is going to be the reference points for me. And I'll consider this point that is towards the right hand side as the reference point on which it is resting as told in the problem statement. So let us just do the annotation. So we'll start from here. So this is the point A on the circumference, followed by point B, C, D, E, F, G, and H. Now let us select the line option again to draw the projection lines to intersect the XY line. B and H intersect the XY line. Similarly, from the end point A, intersect the XY line, and from E, intersect the XY line, and also from C and G, intersect the XY line. So we have also got the point O1 and O here. So O1 is the center point of the circle and O is the apex of the cone. So from this point, we are going to generate the axis line. So select a line of thickness 0.13 and let it be a center line. So from this line, we are going to draw the axis, which is measuring 50 mm. The end point of this line is the apex of the cone. So now let us select a continuous line of thickness 0.50 mm, and from the apex, join the end point of the projection lines intersecting the XY line. So these are the only two slant generators of the cone, whereas the generators from the other points will not be the actual generators. They are just for the construction purpose. So for that purpose, From this point, let me join them to the apex using a thin line. So this completes the front view of the cone. Let us annotate this. So first let us annotate the axis line. This is O1 dash, while the apex is O dash. So this point is A dash, followed by B dash and H dash inside the bracket. And then this is the point C dash and F dash inside the bracket. And we have got the last point, that is D dash. Okay, this is C and G will come here. So just make a correction. So this is D dash and F dash. This point is E dash, and the slant generator is also here from C dash to G dash. So we can just do the annotation here, which is C dash and inside the bracket G dash. So we have completed with annotating the front view of the cone. So now, as per the problem statement, the apex of this cone is at a height of 40 mm from the reference line. So what we will do is we will construct a line, or you can just select the offset option and select the XY line and offset this to a distance of 40 mm. So just select the direction. You can just see that it is at a distance of 40 mm. So on this 40 mm, I need to 40 mm line, I need to have the apex of the cone as per the problem statement. So what I'll do is let me select the front view of the cone along with the base and the annotations. And let me create a copy of this. So just move this copy to the right hand side of the XY line. So this is the first step. And next, what we will do is we will go for arc by center point and then select a construction line of thickness 0.13. From this apex O, I'll just try to cut an arc, or I'll just measure A dash to O dash and then try to cut an arc so that it is going to intersect this, or it is just going to touch this 40 mm line. So this is the point of intersection. So what I'll do is I'll use the trim option, trim this and trim this. So I've got the end point of the arc here. So let me trim even this line. Okay, so now all the lines are trimmed. So now let me select the copy of this front view along with the annotations and also the base of the cone. So now how will we do the rotation is select the rotate option, ensure the copy is off, and then the first point of rotation is this point A, the second point of rotation is the point O dash, and then rotate it until it is meeting the end point of this arc that you have cut in the previous position. and then rotate this until it is meeting the end point of this arc. So now let us trim this arc and also this, go for the distance between the apex and the xy line, and you can see that it is at a distance of 40 as per the required condition. So we'll just ensure that all the annotations are above the xy line to represent the front view. So with this, let us complete the top view of the cone. So select a line of thickness 0.13. So from the apex, draw a projection line. Similarly, from all the other corresponding points, draw the vertical projection lines and the horizontal projection lines and complete the top view. So now we have got the points of intersection of the horizontal and the vertical projection lines. So we'll select the ellipse by 3 points in the circle option and then select the thickness of 0.50. Let us connect the major diameter of the ellipse, which are the points G and C, and also connect the minor diameter point, either the point A or the point E. So any point can be selected. So you can just see that the top view of the circle, which appears to be an ellipse in the HP, is done. So now go for the line option. So ensure the line is also having a thickness of 0.50. From the apex, join it to any point on the ellipse. So do not connect it to any of the end points here. Just ensure that it is making a contact with the surface of the ellipse. That is sufficient. You should not connect the end point to the end point because it is going to move inside the ellipse. So just make a connection on the point on the ellipse. So this is the view. But however, for the observer, the point A dash is the farthest point, and it will be the other side of the cone. So this will be the dotted edge. So we'll just construct the dotted line. So for that, what we can do is we can go for split option. So I can tell that in this entire entity, make a point of split here and here. So you can just see that these are the two entities separated, and I'll select this and make it a dotted one. So this is the top view of the cone. So from the point A dash, this will be the dotted line. So this is the top view of the cone. Now we'll do the annotation. So this is the apex O, and this is the point of axis, which is O1. And here we have got the point of resting, that is A, followed by the point B, C, D, E, F, G, and finally H. So this is the top view of the cone. And to get the axis point for this third position, so what we can do is use the trim option and trim this line into two equal halves so that the point O1 is available for us in the next position to draw the projection lines. So now you can just see that the point O1 is available. And also, to rotate this cone to the next position, we have to trim these lines, or else selection of the cone will become difficult. So just ensure that you're going to select the cone along with the inner rectangle for the next position. So use the trim option, and after we have moved it to the second position, we can go for using the extend to next option. So we are going to select only this part of the cone for the next position. So in the next position, it is very clearly told that the top view of the axis is inclined at an angle of 60 degrees. So which is itself the beta angle. So select a line of 13.13 mm thickness. Draw a line inclined to the vertical plane at an angle of 60 degrees. So now on this line, let us place this cone. So select the cone along with the inner rectangle. If you are not selecting the inner rectangle, you will not be getting the points to draw the projection lines. So ensure that you select the inner rectangle. And then move this, create a copy of it. Point O is the reference point. Place it on the 60-degree line and then go for the rotate option. O is the first point of rotation. O1 is the second point of rotation, ensuring the copies of overlap the axis on the 60-degree line. So this is the 60-degree line. So now use the extend to next option to complete the projections of the previous positions. So now we'll complete the front view of the cone by drawing the vertical and the horizontal projection lines. So now with these points, we can complete the front view. So go for curve and select the curve option. Ensure the thickness is 0.50. So let us start off with the first point, that is A, which is on the reference line. A to B, C, D, E, F, G, H, and H to A. So select the line option of thickness 0.50 mm and then connect this to the apex. Annotate the front view. This is the apex O dash. This is the center of the circle, which is O1 dash. And then we have got the other point. So this is the point A dash. So with this, we complete the problem. So he is asking us to determine the inclinations of the axis. So for that, go for the angle between. So the angle of inclination of the axis here is 26 degrees. That is the value of theta. So with this, we complete the construction of the solution for the given problem statement.